Hi, I'm Krishna. This is day 9 of 30 days of understanding the modern AI stack. So, in this video, we're talking about something that literally changed how machines understand language: word embeddings. So, let me start with a simple question. How does a machine know that banda and bandi are related, but banda and tomato are not? And how does ChatGPT understand that angry, furious, and irritated are practically cousins? It's not magic, it's vectors. A word embedding is just a list of numbers. But here's the twist: those numbers encode meaning. Banda might be a 384 dimensional vector, and Bandi might be another 384 dimensional vector. And the magic is that these two vectors end up close to each other in the AI's mental space. This vector space is basically a giant coordinate system where words with similar meanings sit near each other and words with opposite meanings sit further apart. But why do we even need embeddings? Before embeddings, language models were basically dumb. We used one hot vectors, huge sparse vectors, where every word was equally far apart. In that world, apple the fruit and apple the company had no relationship whatsoever. Embedding solved this by giving words positions based on meaning, not spelling. So the insight that started everything is a legendary idea called the distributional hypothesis, which says you understand a word by the company it keeps. So if doctor appears near hospital and surgeon, and teacher appears near a classroom and students, the model learns that they are both professions, but not the same kind of profession. That subtlety comes from the geometry of embeddings. And here comes the mind blowing part. Think about this. If I take a vector for kin and subtract the vector for man and add the vector for woman, what do you get? You get a vector insanely close to queen. Meaning becomes a direction in space. This single concept is the backbone of everything modern in NLP, natural language processing, search engines, RAG, notebook LLM wala thing, recommendation systems, chatbots, memory systems, and everything. And there are two major styles of embeddings you will hear about. First one is static embeddings, under which we have word to vec, glove, and fast text. These give one vector per word, no matter the sentence. So I ate an apple, and Apple released a new iPhone at the similar embedding, which is old school, for which we have contextual embeddings in the second place. This is what modern transformers like ChatGPT and Gemini use. The embedding changes depending on the sentence. Now, apple means fruit in one sentence and company in another. That's why RAG works. That's why semantic search works. That's why chatbots feel smart. So, if your goal is to build real AI systems, RAG, multi agent systems, automation bots, retrieval workflows, you must understand embeddings because everything depends on comparing meaning. Search, RAG, memory retrieval, recommendation, chunk ranking depends on embedding similarity. So everything modern in AI is built on this foundation. And to get the similarity, we do cosine similarity. It measures the angle between two vectors. If angle is small, high similarity, because both pointing in the same direction. If angle is big, unrelated. If angle is 180 degree, opposite meaning. This is how AI knows that happy is joyful, but happy is not sad. Math becomes intuition. And you don't need to train embedding models from scratch. Just use what's available online based on your use cases. And here's a simple final example. If I embed the word teacher and then embed the word school, their cosine similarity will be high. If I embed the word teacher and tomato, their cosine similarity will be low. That's embeddings in action. So that's all you need to know at an abstract level. So see you in the next video. Let's do it.